Good evening, everyone. Myself Sana Sheikh, a second year PhD student at IIT Bombay, and I am a TA of the course, the NPTEL course named Symmetry, Stereochemistry and Application. And the course instructor is Professor Anshuman Roy Chaudhary from ISL Mohali. This is the week 11 video, and on every Monday, so 7 to 9 p.m., we are giving a live session. In this live session, we are discussing the previous year questions of assignment for this course. So this is week 11 session, and here we are going to discuss the previous year assignment, which is based on the rearrangement reaction. So we'll discuss the rearrangement reaction here. Few rearrangement reactions mechanism we will discuss in detail. Yeah. So this is the question number 1. Here the question is write the mechanism of the following reactions, and the structure is given here, and reaction condition is also given here. So this reaction is looking simple, but the mechanism we have to discuss here because it is a rearrangement reaction. So whenever the two hydroxy group are present on adjacent carbon atom, that time we have to remember that it's a in acidic medium, acidic condition, it's a type of pinacol-pinacolon rearrangement reaction. So the pinacol rearrangement reaction is undergoing acidic condition to give a corresponding product. We will discuss here the product also, and rearrangement mechanism also. So what will be the first mechanism here? Step 1. Step 1 will be the protonation of OH group, that is hydroxy group. Protonation will take place here. This is step 1. So here protonation will take place. Protonation of hydroxy group. So which hydroxy group will undergo protonation? Anyone? So here in this example, we have two hydroxy group here and here. So we can protonate any hydroxy group because the both the carbon atom have same substituent. Like here we have one methyl group, here also we have one methyl group, and the second substituent is this group, and the third one is this one. So both the carbon atom have similar substituents. So it will protonated here. Any OH group will be protonated. So here I am doing protonation on this OH group. Okay, so I am writing here. OH2 protonation, and this oxygen will carry the positive charge, oxonium ion. And here methyl group, everything will remain same. After protonation, what will happen? Methyl group. Okay. So the second step is loss of H2 molecule and the formation of carbocation. So where the loss of H2 molecule will take place, where we have protonated the OH group. So from here, this OH H2O group will be eliminated, and carbocation formation will take place over here. Here OH is the amine group, here we have amine group and carbocation formation will take place here. Okay, so after carbocation formation, what will happen? The third step will be the methyl migration on the carbocation or any group migration on the carbocation. First we will do the methyl migration, then I will discuss the other group migration. So why the migration will take place? Because it will undergo stability of carb. It depends on the stability of carbocation. As tertiary carbocation stable, and it will that's why it will undergo migration. So this methyl group, this one will be migrated to this carbocation, carbon atom. So after migration, you will observe here carbocation formation will take place on this carbon atom. This OH group is here and methyl group has migrated, plus positive charge will come on this carbon atom. Here we have two methyl groups. Methyl group. Now after formation of this carbocation, the next step will be the deprotonation step. So in deprotonation step, this hydroxy group proton will deprotonated to give the carbonyl group. So deprotonation will be done by H2O. H2O will take the proton. H2O will take the proton to give the, and this bond will come here to give carbonyl group here, carbonyl along with two substituent of methyl group. So this is the product formed in this rearrangement reaction. This is the pinacol-pinaclone arrangement reaction. So is there any other possibility for reaction? Anyone? Is there any other possibility? Yeah. Any other possibility is there? The second, this is the first product. So we will talk about now the second product formation in same reaction. So how we can decide the which product is the major one and minor one? We will discuss that thing also. So here again we have discussed all the four steps. First step is, what is the first step? Protonation of hydroxy group. The second step is loss of H2O molecule. Correct? The second step is the loss of H2 molecule, and the third step is the methyl migration or alkyl migration and alkyl group migration, and the fourth step is deprotonation step. So let's talk about the other product. So if the second possibility is here, I am writing here. If after protonation any group will be get protonated. Correct? Or I can write here directly. Here. Here. After protonation, we can draw the chair conformation to better understand the elimination of the group. This is a chair conformation. So here we have OH group, correct? On axial position I am drawing it. On axial position, OH group. So OH and Me group here are opposite direction. So on equatorial position we have methyl group, correct? Now here you can see that both the hydroxy group are trans to each other, and both the methyl are also trans to each other. Trans means in chair conformation on adjacent carbon atoms, 1 2 addition, 1 2 substituent. What will happen? Trans means they will undergo axial opposite direction. Like if it is a axial hydroxy group, then the other hydroxy group is trans to this one. That means it will be on downward direction, hydroxy group. And methyl group are both the methyl group are trans to each other. That means it will on opposite direction. That is equatorial position. Remember this one. This is upside. This is upside. This axial is upside, right? This equatorial is upside. Upside will give a cis product. Downside will give a trans product. So here both the hydroxy group are trans. That's why this one is upside on axial position. This one is downside on axial position. And here methyl group are trans to each other. So this is a downside methyl group, and this is upside. That means these methyl groups are trans to each other. Now if I will protonate this hydroxy group. Suppose this hydroxy group is get protonated. I have drawn from here. This is okay, not this one. So if deprotonation will takes place here, so this group will, sorry, this hydroxy group is protonated, getting protonated. I am writing directly. Please understand here because it's become difficult to draw. This is OH group, positive charge, and then this OH group will be eliminated to form a carbocation over this carbon atom. 1 2, carbon number 2. Okay, so this is the chair conformation. Here carbocation formation will take place. Here hydroxy group. Now whenever we observe the elimination, here when H2 is getting elimination and eliminated, what will happen? The trans to the bond which is trans to this OH will be the breaking bond. That means that bond will break, which is trans to OH group. So here you can see that trans to OH group is hydroxy group. So hydroxy group cannot be eliminated. So in this case, methyl group can be eliminated. But the second case is here when both the hydroxy group will be on equatorial position and methyl group on axial position. Here I am drawing the second case. Here both the methyl group are on axial position. This is also the possibility, correct? Methyl group, this is OH group, here also OH. So when this OH is eliminating after protonation, then carbocation formation will take place here. This is methyl, carbocation, OH, methyl, correct? So here you can see that trans to this hydroxy group. Here this hydroxy group is getting eliminated and carbocation formation is taking place. So this group is all can also be migrate here. This group can also be migrate here. So when this group is migrating over this carbon atom, what will happen? 5-member ring formation will take place. 5-member ring formation. So here we will observe 5-member ring formation along with carbocation formation over other carbon atom. Methyl and OH. I will draw in same manner, then better to understand. So here we have this way, right? This carbon will be migrated over here and this methyl group was present here earlier. Here methyl, here OH, carbocation. Okay. Then protonation will take place. Deprotonation will take place here. First was the protonation, the last step is deprotonation. So deprotonation will be takes place here and the bond formation, the carbon oxygen double bond formation will take place to give the desired product, that is ketone. 5-member product. Methyl group and here also methyl group. So these are two possibility of the product in this case. The first case, if the first product is 6-member ketone, 1 to 1 1 we can say here 2,2-dimethyl cycloketone, hexacycloketone. And here we can see this is a 5-member ring ketone, and this is a product 2. This is a product 2. So these are two product formation will takes place by pinacol-pinacolone rearrangement in this question in acidic medium. So I hope all of you are understood. So we can go for the next question. So here we can see that this is a amide given here. All of you can see here. Here we have amide, carbonyl group and NH2. So whenever carbonyl group and NH2 are present in halogenation condition, here we have given a Br2 in the reaction condition Br2 and sodium hydroxide water. So whenever we have given this condition, that means this is a reaction of Hoffman rearrangement. Hoffman rearrangement reaction. So in Hoffman rearrangement reaction, what happens first? First, the deprotonation of amide and nucleophilic attack of X2 takes place. So how we will do the nucleophilic attack and deprotonation of amide? So this nitrogen have NH2, right? This is amide group. As I told you, this is the amide group. I will write here openly. Okay. I'm writing here the whole mechanism. We have pH, CH2, correct? And then carbonyl, then nitrogen, and nitrogen has 2 protons, correct? So then here the deprotonation will take place from nitrogen. So OH minus, that is we have here in this reaction condition, OH minus will abstract the proton from here. Any proton will be get abstracted. Okay. So after proton abstraction, after deprotonation, what we will get? See, the whole group is not getting affected. This phenyl and CH2 group will remain as it is. Only the reaction is taking place as at amide position. So then this amide will become here NH minus, correct? After deprotonation, it will become NH minus. The very first step. Then halogenation will take place. Nucleophilic attack of halogen as bromine 2 will be takes place here. So we have this bromine 2 here, bromine 2, and this negative charge will attack over here. Nucleophilic attacks will take place, and we will get the corresponding intermediate here, which is nothing but pH, CH2, carbonyl, NH and Br. Correct? Then this is the first step. What will be the second step? In second step, deprotonation takes place followed by the migration of the alkyl group. Again, because we are doing the rearrangement reactions, in rearrangement reactions, the migration is taking place in the reaction. So first we will observe here the deprotonation again. So now the for deprotonation only one proton is available, correct? Deprotonation will take place. Here. So what will be the intermediate? Again pH, CH2, carbonyl group, so here Br will be here and negative charge will be generated on nitrogen atom. So after getting this intermediate, the migration of alkyl group will take place. So what is alkyl group here? Here phenyl and CH2, this benzylic group is our alkyl group or aryl group. Any migrating group here it is there. So it will migrated on nitrogen atom. So we will get the isocyanide formation over here. How it will be isocyanide? I will write here. This is our oxygen, double bond, carbon, and this is our nitrogen here. This group will migrate over here, and this halogen will be eliminated. Bromine. Okay. So here we will get the product. CH2 phenyl group. Correct? Why I am writing here N double bond C? Here you can see that this N is negative charge, negatively charged. So it can be written in a inolate kind of form, like this nitrogen carbon form double bond and oxygen will carry the negative charge, like this way, this way. we can get the negative charge on oxygen atom. Then this will migrate over here and it will be eliminated. Then again this negative charge will push here and we will get this as a intermediate product. This is isocyanide. This intermediate is known as isocyanide. Okay. Then this isocyanide will react rapidly with the water to form the carbamic acid here. So this isocyanide now undergo reaction with water because we have water also in a reaction condition. So how it will react? I am writing here only. OH2, correct? It will attack on this carbon and this bond will be break this way. Okay, and it results in a formation of carbamate carbamic acid. Here I will write here first CH CH2 nitrogen double bond C O minus and H2 is attacked here. We will get here this way. Positive charge will come over here. So this is called the intermediate formed by H2O attack here. But then what's the next step? So this O negative will push over here, this O negative, and this nitrogen will get protonated. So this double bond will attack over here to give the carbamic acid. So the structure for carbamic acid I will write here only. So instead of CH2 group I am writing here because of the space problem. So uh, just understand this is R is nothing but the phenyl and CH2 group, and this is NH which I have written here, and then this carbon will have a C double bond O here and COH here, correct? So this is nothing but the carbamic acid formation takes place in third step. So what's the first step? What was the first step? Deprotonation of amide, right? Deprotonation of amide followed by nucleophilic attack of halogen X2 or Br2. Here we have Br2. So and the second step was the deprotonation followed by migration of alkyl group. Deprotonation followed by migration of alkyl group. And the third step is isocyanide reacts rapidly with the water to form the carbamic acid. And the last step is here, which is carbamic acid releases CO2 to form the product. So I will write here I hope this is all clear to you. So I will write here. Can I erase this one? I'm writing here the next step. So what we got in last step? Carbamic acid. I'm writing here P H CH2 PHCH2 nitrogen H, and this was the carbamic acid here, and OH will be here. Correct? So we got this from third step. Now this carbamic acid will release the CO2. So how it will react? So OH minus will attack on here. Again deprotonation will take place. This is OH minus. It will take proton from here and this will take place here. This is arrow. Okay. So CO2 release will takes place here. So what we will get here? Oh, pointer, no? This pointer. Okay. So here we have pH. CH2 and H and negatively charged. Correct? Plus CO2. Plus CO2. As I told you, CO2 will release here. So we get plus CO2. Now in next step, water molecule is there. So it will protonate the nitrogen atom. So protonation will takes place again. This is water. It will attack over here. Here. And we will get amine formation. pH CH2 and H2 NH2. Correct? This is amine formation. So this will be the byproduct. So this reaction was a Hoffman rearrangement reaction. So when the Hoffman rearrangement reaction will take place, whenever we have amide group and it's given in a halogenic condition, that we can see here bromine was given in basic medium NaOH and H2O was given. So the first step for this reaction was deprotonation of amide and nucleophilic attack, followed by the nucleophilic attack of Br2. So here the deprotonation was takes place on nitrogen atom, and then Br2 Br2 attack was takes place on the same carbon atom to get the intermediate which contains the NHBr. Then the second step was the deprotonation followed by the migration of the alkyl group. So in first step deprotonation followed by the nucleophilic attack was take place. In second step deprotonation followed by the migration of alkyl group. So in the second step again the remaining proton or nitrogen atom was deprotonated, and this pH CH2 group was migrated on this nitrogen atom to form the isocyanide. Then isocyanide formation was undergo again. Isocyanide reacts in third step rapidly with the water to form the carbamic acid. In third step we got the carbamic acid formation, and in last step the carbamic acid releases the CO2 to form the amine here. So we got the product amine here. I hope all of you are clear in this rearrangement reaction. Now let's talk about the next one. Yeah, which type of rearrangement reaction is this? This is the Bachmann rearrangement reaction. So what happens in Bachmann rearrangement reaction? An oxime, here you can see that this is oxime, which is converted to an amide in Bachmann rearrangement reaction. So an oxime is formed by creating an aldehyde or a ketone with hydroxyl amide. So the formation we will not discuss here. I am going to discuss the mechanism for this rearrangement reaction. So we will discuss the mechanism. What happened in this reaction? Here we have ketoxime, and so the OH group of this ketoxime or aldoxime we can say can become a leaving group by tosylation. So what will happen? I will write here. This OH group will get protonated to give the intermediate pH nitrogen double bond. This is oxime, and this will become OH2. Correct? OH2. Okay. So this plus charge will be on this oxygen atom. So this alkyl group, which is trans to OH group. Here you can see this phenyl group, and here OH group. And phenyl group is trans to OH group. So the phenyl group will migrate here. The alkyl group, which is present trans to the hydroxy group, will always migrate in this rearrangement reaction. So here phenyl group will migrate over here nitrogen atom, and this H2O will leave. H2O group will leave here, and nitrogen will form here pi bond with carbon atom with this carbon atom. So here I am writing product minus H2O. Correct? H2O will leave here. Minus H2O will give here methyl, because phenyl group is migrated. So I am writing in this way only. Here methyl carbon. I am talking about this carbon atom. Triple bond nitrogen, and nitrogen has now substituent which is phenyl. Positive charge will come on this nitrogen atom. Okay. So this is a nitrilium ion. This is called the nitrilium ion. Now again water molecule will abstract the proton. Sorry, proton is not there. So water molecule will attack on this carbon atom to give the corresponding intermediate. I am writing here methyl double bond nitrogen phenyl, and here O H. And this rearrangement will take place. This proton will be taken by this nitrogen atom, and the carbon will C carbon oxygen double bond formation will take place to give the keto to give the here product. What is the product? Methyl, correct? C double bond O and H, and the second substituent is our phenyl group, correct? So this will be the product. So what happened in this reaction? The OH group of the ketoxime here get protonated here, and it's become a leaving group, good leaving group. And after leaving of this H2O group, the phenyl or alkyl group, which is trans to OH group, was migrated on nitrogen atom, and form this nitrilium ion intermediate. Then this nitrilium ion intermediate undergoes reaction with H2O to give this intermediate, and then the migration of proton takes place to give the corresponding product. So I hope this rearrangement is clear to you. This is a Bachmann rearrangement, and it's a stereo specific, and because the group present trans to OH group is always magnet, that's why it's a stereo specific. Okay, so I hope the mechanism is clear to you. So we will move to the next question. Yeah. Which type of rearrangement is here? Which type of rearrangement reaction is this? This is the Claisen rearrangement reaction. Claisen rearrangement reaction. So what happened in Claisen rearrangement reaction? So here allyl aryl ethers here. Here you can see this aryl group. This is allyl group. So allyl aryl ether undergo Claisen rearrangement when heated to 200 degree. Here heat is mentioned here. That means it is heated. So heated about 200 degree or approximate 200 degree in an inert solvent. So CCl4 is a inert solvent. In the presence of inert solvent, so this reaction involves the migration of allyl group from ether oxygen atom to the ring carbon ring carbon at the ortho or at the para position through a concerted reaction mechanism. So we will discuss here how the mechanism is going. I will write here concerted mechanism. That means there is no carbocation carbon ion formation will take place and no cross product will also here. So I will write here the rearrangement type reaction. This is one. First you have to give numbering this way 1 2 3 next to the carbon atom which is next to the oxygen atom or ether bridge we can say, we will give the first number 1, and the other side oxygen will get the first number 1, and the second this carbon, and the third number will be given to this carbon atom. So you can see 1 2 3 1 2 3, right? Now in rearrangement reaction what will happen, one bond will get break here. The bond and new bond formation will take place between 3 carbon atoms. So the next new bond will form over here, which is called as concerted mechanism. That's why I'm showing here with dotted line. Dotted line. So here I will show the intermediate. This is dotted line. And this will also a dotted line. Here the bond which is breaking here and the bond which is formation is taking place, I am showing with dotted line. Both the bond with dotted line. This is called a concerted mechanism. Bond breaking and bond making takes place simultaneously. That's why it's known as concerted mechanism. And other two pi bond will remain as it is. Okay. So here, as I told you, 3 bond formation will take place and 1 bond breaking takes place. So after bond breaking, what will happen? Here again the bond formation will take place. Bond formation between 1 and 2, and 3 bond formation, new bond formation, sigma bond formation in between 3 carbon atom will take place here, and this double bond will be migrated to 1 2 position. So you have to just remember the numbering, that's it. Then you can draw the whole molecule. So here we have formed the 3 bond, correct? 3 bond. The methyl group was here. You can see here 3 are now bonded, correct? Now 1 2 bond are break. 1 2 are break. So between 1 2 bond are break. So 1 2 between 1 2 double bond formation will takes place. So here also double bond, correct? 1 2. Now everything will remain as it is. So this is a product, but this is not the stable product because this is the aromatic system. So it will get stabilized by undergoing a ketoenol formation to form the cyclic aromatic ring. So here we have proton. Here we have proton, which will give here this type of reaction. This oxygen will abstract this proton to give the alcohol, aromatic alcohol, which is a stable product because of the aromatization. Correct? and this is the transition state. Transition state. So this comes under pericyclic reaction, or in this reaction, Claisen rearrangement reaction. The intermediate is the reaction product is achieved by concerted mechanism. So this is called the Claisen rearrangement reaction. I hope all of you are clear here. So we will move to the next question. Yeah. Which type of rearrangement reaction is this? This is a Cope rearrangement reaction. So Cope rearrangement reaction is an example of sigmatropic rearrangement reaction, like Claisen rearrangement reaction we have done. Here we have 3-3 sigmatropic shift because 3-3 bond formation was taking place and 1-1 bond was breaking. So this type of reaction is called as 3-3 sigmatropic reaction. The same Cope rearrangement is also a 3-3 sigmatropic rearrangement, but here we don't have heteroatom involvement in the 3-3 sigmatropic reaction. In previous case, here we have oxygen atom in 3-3 sigmatropic reaction, but here we don't have any heteroatom, only carbon-carbon uh, bond will participate in the 3-3 sigmatropic reaction. So here again we have to give the numbering in a similar way, like I am giving numbering here 1, 2, 3. But whenever you are giving numbering, just remember that the 2, 3 will always carry a double bond. 2, 3 numbering will always carry a double bond. Then only you will get the desired product. Then 1, 2, 3. So here you can see that 2, 3 have double bond, 2, 3 have a double bond. And 1, 1 is a sigma bond. Now, that here again it will undergo by concerted manner. So I will write here transition state OMe. OMe. This is a bond formation. This is bond breaking. Here also bond breaking. 2, 3 bond will break. 1, 2 bond will form. And this is also a dotted line. Don't consider this full line. And this is the transition state. 6-member cyclic transition state we will observe here. And the formation of product will take place here. This is cyclic transition state. I am writing here transition state, cyclic transition state. So what will be the product? 3-3 bond formation will take place in product, but the 1-1 bond will getting break. So OMe group will come here. Correct? Here we have OMe group. And bond formation will take place between 1, 2 and 1, 2. So this is the new diene product, which is getting after 3-3 sigmatropic shift of this corresponding diene. So this is a concerted mechanism. So reaction proceeds through a cyclic transition state, and the transition state is general adopt a chair conformation. So here it is undergo with chair conformation. I am writing here. Suppose this is a chair. OMe. Here we have double bond. Here we have double bond. 1, 2, 3. 1, 2, 3. This is OMe group. So, if you are not understanding the chair conformation, I will explain in the next lecture in detail, but you have to ask me. So here we have the transition state via chair conformation. It adopts the chair conformation transition state to give the corresponding product. So finally we will get this product only. So I am writing directly here because it's become difficult to draw. So this is a product we got in Fock rearrangement reaction. Okay. So I hope this rearrangement reaction is also clear to you. So we will move to the last question which is given here. So which type of rearrangement reaction is this? Any guesses? Yeah. Here we have a halogen group in a reactant. That means it's a price rearrangement reaction. So when a phenolic ester is heated, this is a phenolic ester. Sorry, this is not a phenolic ester. This is a, okay. So how the rearrangement reaction product is formed? So when a phenolic ester is heated in an inert solvent in the presence of a suitable Lewis acid as a catalyst and the product is hydrolyzed, a mixture of ortho and para or acyl phenol is obtained. Sorry. So this is a another type of rearrangement reaction. Here we can see that we have alpha haloketone, correct? Okay. So in this reaction, okay, you can see here we have a alpha haloketone. So in Favorsky rearrangement reaction, the reaction of alpha haloketone with a base to produce a rearranged acid or ester is formed, which is called a Favorsky rearrangement reaction. So I will write the mechanism here. So in step 1, what happens? Abstraction of alpha hydrogen takes place. So what is alpha hydrogen here? This we have a carbonyl group, and this is alpha proton. This one is also alpha proton, but the abstraction will take place from this alpha position, which have two alkyl groups. So here the abstraction will take place to give the pH, carbon, Me group. Negative charge will generate over here because the proton abstraction is taking place, and then carbonyl group, then the next carbon which has halogen atom Cl, and proton and alkyl group, right? So the carbon atom which has only alkyl substitution will undergo a proton abstraction. Then this is the first step, abstraction of alpha proton. Then the in second step intramolecular SN2 reaction will take place to form a cyclopropane ring. So here intramolecular SN2 reaction will taking place. This C manase will attack on this carbon atom, followed by elimination of this halogen group. This is SN2 reaction. Okay, so we will get here cyclopropane ring intermediate. So PH bond carbon Me group, cyclopropane ring, correct? This is carbon double bond carbonyl, right? This carbon atom, and this one is the carbon atom which has proton and CH3 group. Clear this intermediate? This is this carbon atom, this C negative, and it will attack on this carbon atom to eliminate the Cl group SN2 type reaction to give this cyclopropane ring. So this is the carbon, the third carbon, which has two substituent, that is proton and CH3 group, and this is the carbonyl group carbon atom, and the third carbon atom is here. So this is the second step. Now the third step is cleavage of cyclopropane ring will take place. So here the third step where the cleavage of cyclopropane ring will take place. So what happened? OH minus, we have here base. So OH minus will attack on this carbonyl carbon atom here. This carbonyl carbon atom, and this will happen like this. Sorry. It will attack over here. It will give this way, and we will get the intermediate PH carbon methyl carbon methyl hydrogen. Here what will happen now? C O bond, negative charge will generate over here, and OH will attack on this carbon atom, so we will get OH. Okay, OH. Now what's the next step? The fourth step is absorption of H from H2. So here abstraction of proton will take place. First, this negative charge will push over here, form a bond, and this bond will break. Cleaving of pro, cyclopropane ring will take place in third step. Then in fourth step, extraction of proton from water will take place. So after cleaving this cyclopropane ring, what we will get? We will observe the intermediate. I will write here PH carbon methyl carbon methyl H C double bond O OH acid, correct? Acid formation will take place and negative charge will come on this carbon atom. Carbon ion will generate here. Carbon anion will generate over here, and this carbon anion will attack on water to abstract the proton. Will abstract the proton from water. I will write here. Here it will abstract the proton to give the corresponding product R, or we can write here pH. pH C Here we have methyl group, correct? Here we have acidic group. I am writing directly here. Which acidic group? You can see here, this one. This is the acidic group we have here. Okay. So this is the acidic group here. Then carbon atom. This carbon atom, which is carbon anion in previous step. And after abstracting the proton, it will become CH Me CH2 Me. Sorry, one proton was there previously. CH2 Me. So this is the product we will get in this type of rearrangement reaction. So here we are getting the acid formation here. And this is the which type of rearrangement this is? This is the Favorsky rearrangement reaction. Correct? I hope all of you are clear with the mechanism. So we will here summarize the today's lecture for your better understanding what we have done. So in we have done the several questions based on the rearrangement reaction. So the very first question was there here. The mechanism of the following reaction was asked in this assignment question. So the very first question, which is the example of pinacol-pinaclone rearrangement reaction, and in this pinacol-pinaclone rearrangement reaction, the in first step protonation of the OH group was taking place, and then in second step loss of H2 molecule and the formation of the carbocation formation was take place. Formation of carbocation is generated here, and in third step the methyl migration on carbocation is take place. So here we have the two types of migration. Either the methyl group will migrate to give this 6-member cyclic ring product, or the alkyl group will migrate to give the 5-member cyclic ring product. So the last step was the deprotonation step. As you can see here, we have discussed in detail. So there are 4 steps in pinacol-pinaclone rearrangement reaction in acidic condition at high temperature. So then we have discussed the second question, which is the example of Hoffman rearrangement reaction. So Hoffman rearrangement reaction is given here example. So in the presence of strong base, primary and secondary amide react with the chlorine, bromine or any other halogen to form a certain amine with the loss of alpha carbon atom. So here we have observed here the reaction mechanism was followed step by step. The first step was deprotonation of amide. Here we have discussed earlier. Here it is not shown because I have erased it. So the first step was deprotonation of amide and nucleophilic attack of H2 on this nitrogen atom. Then in second step, the deprotonation was followed by migration of alkyl group. So this alkyl group was migrated on nitrogen atom to give the isocyanate, and that isocyanate was undergoing third step reaction, which is the reaction with water molecule. So isocyanate reacts rapidly with the water molecule to give a carbamic acid. Here this is a carbamic acid, and this carbamic acid releases the CO2 to form the amine here. In last step, in step 4, it releases the CO2 group to form the amine here. So I hope all of you are clear in this step also. So the third rearrangement reaction we have discussed in this lecture is Bachmann rearrangement reaction. So in Bachmann rearrangement reaction, an oxime is converted to an amide. An oxime is converted to an amide here. You can see amide. So an enzyme is formed by trading an aldehyde or ketone with hydroxylamine. The formation you will find in the previous or in a lecture which is available on YouTube, the formation of oxime. So here we are discussing the mechanism only, mechanism of Beckmann rearrangement. So hydroxylamine, uh, here the OH group of this ketoxime, OH group of this ketoxime can become a leaving group for tessellation. So here the trans group present here, trans to the OH group, will always become a leaving group. So this is a stereospecific reaction. That's why we are getting only stereospecific product. So the leaving group which is trans to OH group will always give a desired product. It always behave as a leaving group which is trans to OH group. So here you can see that protonation is taking place in first step, right? Then after protonation, the migration of phenyl group will take place on this nitrogen atom to give the this nitrogen ion intermediate, and this nitrogen ion intermediate will undergo reaction with H2O to give the amide as a product. So I hope this rearrangement reaction is also clear to you. So next example was the example of rearrangement reaction, which is called as Claisen rearrangement reaction. So in Claisen rearrangement reaction, we have allyl and aryl group. Allyl ether is there. So aryl ether undergo Claisen rearrangement when heated to the approximate 200 degree in an inert solvent. So here heating condition is mentioned. CCl4 is the inert solvent to give the corresponding product. So this reaction involves the migration of allyl group from ether oxygen atom to the ring carbon at the ortho or a para position through a concerted reaction mechanism. So this is the cyclic transition state mentioned here, and this reaction undergoing concerted manner. 3 sigma tropic shift will take place to give the corresponding product. And again, after getting this product, it will undergo tautomerization to give the stable alcohol aromatic product. That's why we are getting here this alcohol as a product, phenol. Sorry, this phenol as a product. So this reaction takes place in concerted manner. There is no cross product formation is possible. So I hope this rearrangement is also clear to you. So the next rearrangement here is Cope rearrangement. Cope rearrangement is a similar type of Claisen rearrangement. Only the difference is that here we don't have any heteroatom here. This is also a 3 sigma tropic shift without a heteroatom including in 3 sigma tropic shift. Here we can see that oxygen is involved in 3 sigma tropic shift, but here it is not there. So this is again a concerted mechanism which is followed in a similar way as a Claisen rearrangement reaction. So here we can see that 3-3 bond formation is taking place and 1-1 bond is breaking here. This is a cyclic transition state, and the product formation will take place here by new bond formation at 3-3 position. Sigma bond formation will take place here, and this bond breaking will take place to give the corresponding product. So I hope this transition state and rearrangement reaction is also clear to you. So the next we have discussed here, the last one, which is Favorsky rearrangement reaction. So in Favorsky rearrangement reaction, the reaction of alpha halo ketone, this is alpha halo ketone with a base here, OH minus is representing the base, to produce a rearranged acid or ester is called a Favorsky rearrangement reaction. So here we are getting a acid, not ester. If we will have other group, we will get ester also. So in this case, we are getting a acid. So what will happen in first step? First step. So in step 1, the abstraction of alpha hydrogen will take place. So alpha proton will abstracted by this base to give this intermediate, and then this negative charge will attack on this carbon atom for in a SN2 manner to give the cyclopropane ring. So intramolecular SN2 reaction will take place here to give the cyclopropane ring. Then this cyclopropane ring will undergo cleavage to give the corresponding intermediate. How it will undergo cleavage? So the OH will attack on this carbonyl group to give this cyclopropane ring intermediate, which is further undergo reaction. This negative charge will attack on push over here to break this carbon-carbon bond, and it will give this carbon anion intermediate formation. Carbon anion will generate over this carbon atom. Then in last step, the abstraction of proton will take place from water. So water will give the proton. This carbon anion will abstract the proton from water to give the corresponding acid as a product. So this is the Favorsky rearrangement reaction. So I hope all of you are clear with all these rearrangement reaction mechanism. If any doubt, any question regarding these questions are there, you can ask me in next lecture. Thank you so much for your kind attention.